In the name of Allah, the Compassionate and the Merciful. Hello guys. In this video, we are going to have a moment curvature analysis of concrete section in Python. You see in here, we have a rectangular section with 6 layers of steel rebars with different distance, as you see. So we use Newton-Raphson for calculating of this converge of this moment curvature analysis, and at the end plotting all output data. So at first I wanted to show you the strain-stress relations of these concrete and steel rebar relations. You see, we use bilinear relations for steel rebars. For compression and tension areas, we use this function and this shape for compression areas of concrete section, and these relations, linear relations for tension areas of unconfined concrete section. And after running the moment curvature analysis, we are going to output the section moment ductility ratio and overstrain factors, and even the flexural rigidity of the elastic area and plastic area. So let's see the Python code. You see in here, we define width and height of concrete section, and defining the layers areas, as you see, distance of each layers, and defining the concrete properties, steel properties, you see in here, and number of layers. I defined 1000 layers for concrete section as a fiber, you see. Number of iterations, tolerance for better converging of our analysis. You can change it with your own. And you see in here, I defined the moment curvature analysis function. You see all input data comes to this function, and then analysis is going to be started. In each step, all strain and stress relations between concrete and steel area is going to be calculated in each layers, and then in all summations comes in here, and then with Newton-Raphson method residual stress is calculated, and if it is converged, so the next step and next increment is going to be restarted again with new strain at the top of the concrete section. And you see, if the problem is converged, we're going to output of each step concrete and steel sections output. You see in here for outputting our concrete strain and stress and steel rebar. You see in here at the top and lower layer of the steel rebar, you see, and even crack depth of this concrete section is going to be calculated. And you see moment curvature, it's going to be output in here, and you see, and if the moment reached the ultimate strain as we defined before, so the analysis is going to be finished. So, and you see that moment curvature relation is non-linear. So if you wanted to linearize it, we use bilinear curve method for linearize of our model. Okay, so our input data for this function we use curvature and moment. So in this function, so two linear behavior of this curve is going to be calculated. After that, Lux chart flexural rigidity and plastic flexural rigidity is going to be calculated. After that, ductility ratio and overstrain factor also is going to be calculated. Then at the end, all output data it's going to be shown. So let's see the result. If we run the code, you see in each increment iterations and strain neutral axis, curvature and moment of this analysis is going to be shown and calculated. And after 19 increments, unconfined concrete section reached to ultimate, and then bilinear relations between this moment curvature analysis is to be going to be calculated and shown in here, and also ductility ratio and overstrain. So if we going to plot it, and you see in here relations between top concrete section and crack depth of this concrete section, neutral axis and top concrete strain, and you see curvature and top concrete strain. You see that it is like linear relations. So you see the flexural rigidity of each increment of concrete strain and flexural rigidity with neutral axis. You see this, it has this behavior, and you see that steel rebars of top and bottom of concrete, this concrete section is shown in here. It shows that bottom steel rebar it has more strain and stress relations, and with a little increment of this curvature, so it goes to reach to ultimate stress and strain after this incrementation. So you see that the concrete fiber concrete section, and you see at the top of concrete section relations between concrete and stress, it seems that it goes to reach to ultimate. And after all, we see that unconfined concrete section moment curvature analysis with two curves. The blue one is the real behavior of our analysis. As you see, it has nonlinear relations, and you see in here, the red one, it shows the bilinear curve fitted of analysis. So we use bilinear curve fitted analysis for better calculating of moments in yield and moments in ultimate, and relations between elastic flexural rigidity and plastic flexural rigidity. So thanks guys. I'd be glad to know your opinion about my modeling. Please have a comment and tell me now. Bye.